right, my friends, it didn't say I had to solve it by graphing, which I'm grateful for. So I'm just going to go ahead and get started on solving this one by substitution. So taking that expression that's equivalent to y in row 2 and replacing y in row 1 with it would yield the opposite of x squared plus 3x plus 1 would equal x cubed minus 2x squared plus x plus 3. And boy, oh boy, do we have more than one x term. So let's get 0 on one side. So hopefully we can factor the non-zero side and use the zero product property. I personally prefer for my highest powered term to have a positive leading coefficient. And for that reason, I'm going to move the equation that's on the left side here over to the right side. So okay, so now I have 0 on one side, and then on the other side, I'd have x cubed minus x squared minus x, it looks like, and then plus 2. Did I do that right? Oh, no, minus 2x. There we go. Maybe that looked a little funny. There we go. Okay, and then at this point, I do hope before you reach for rational zeros theorem, which is the P over Q thing, that you do consider factoring by grouping. And so if you look at this polynomial as in terms of two groups of equal size, then you'll notice that there's a GCF for the first group of x squared, and then there's a GCF for the second group of, I think I would factor the -2 out. And then let's see what happens when we do that. So we'd have x squared times x minus 1, and we'd have -2 times x minus 1. And what about this says that we're getting away with factoring by grouping? It's that we have this common factor here. And so I'm just going to go ahead and factor that out front. So we'd have x minus 1 times the quantity, x squared minus 2. Okay, and then up to you what you want to do with this quadratic factor here. I personally think of it as a difference of two squares. And so a note 2 is equal to the square root of 2 squared. And so that's why I think of that as a difference of two squares. So I just factor it like this. X plus square root 2 times x minus square root 2. There we go. Okay, and it doesn't really matter exactly how you get your answers. So if you didn't factor it and instead you set x squared minus 2 equal to 0 and solved, as long as you got both those answers, then we're all good. Okay, so now let's figure out what our y coordinates would be that go along with these various solutions. So I just got three solutions. I got x equals -1, and then I got x equals negative square root 2, and I got x equals positive square root 2. And then you can back substitute into either equation. I'm going to go ahead and use row 2 because it is a little bit easier to work with. And so my y value when x is -1 would be whatever this equals. Let's see, that would be -1 minus 3, so -4, and then plus 1 looks like it's -3. And so I just got a solution. I'll just make a list of solutions down here at the bottom. So the solution I just got is when x is -1, y is -3. And then y when x is equal to the opposite of square root 2 would be whatever this is equivalent to. So let's see, exponents first. So the opposite of square root 2 squared would be 2, but then you have to negate it. So you get -2 minus 3 root 2 plus 1, which, let's see, simplifying that, I'd get -3 root 2 minus 1. Okay, so the point of intersection that comes with that one would be negative root 2 and then -3 root 2 minus 1. Okay, let's write a little smaller here. All right, and then when I think I'll show it over here. My y value when x is equal to square root 2 would be the opposite of square root 2 squared plus 3 times square root 2 plus 1, which would be negative 2 plus 3 root 2 plus 1, which would be 3 root 2 minus 1, like so. So when x is positive root 2, the y-coordinate would need to be 3 root 2 minus 1. There we go. And these would be my solutions. All right, my friends, hopefully this makes sense. That is it for section 7.1. I hope the 7.1 problem set goes well. In section 7.2, we will talk about introducing the process for solving systems of equations known as elimination. We'll use that process sometimes, and then we'll also do some story problems. Take care, everybody.